ladies and gentlemen. As Deborah said, my name's Mark Roberts. I'm the Market Development Director for BP Castrol across Asia Pacific. I think liquid cooling is quite a hot topic. There's been a number of presentations about it today, and I'm going to talk about the importance of collaboration within the liquid cooling ecosystem, and hopefully share some insights and points of interest for you today. So without further ado, I just want to first of all ask a question, maybe for the guys that are sat in front, and maybe anybody else in the building. In liquid cooling, should the fluid have direct contact with the IT equipment? Okay, so is it yes? Let it swim like a fish. Is it B? Hell no, that server's worth 300K. Don't ask me, can't we just throw more air at it? Or D, it depends. So, any hands for A? No. Okay, we've got a couple. B? No. C? No. I think we had D, didn't we? Yeah, absolutely, 100% depends. So let's try and talk about that and prove that as we go through this presentation today. So just in terms of the agenda, we'll just talk about why am I here? BP Castrol, you probably don't associate with the data center, so we'll just clear that up first of all. We'll also talk about the liquid cooling landscape and where we see the industry and the adoption at the moment. We'll talk about some of the technologies and why those technologies require that collaboration and for us all to be working together. And then we'll just set some context and how we're working with the industry and how we can work with you guys as well. So, as I mentioned, BP Castrol is probably not a name that you do associate with the data center industry. However, BP is transitioning from an international oil company to more of an integrated energy company. And as part of that transition, we've got some very strategic pillars that we're trying to achieve, one of which is helping industries and segments to decarbonize. And when we think of the data center industry, we know it's a big, power-hungry monster, and it's an obvious place for us to try and support the decarbonization. So when we look at BP, we have renewables, we have investments in hydrogen, we have investments in geothermal. But one of the biggest brands within our business is the Castrol business. And you probably know, I know Castrol is very strong here in India, and Castrol has fluids for many different types of application, and we had the opportunity a couple of years ago to enter the market with our fluids for immersion cooling technology. So our main aim is to actually drive the adoption of liquid cooling, and in order to drive efficiencies, reduce waste, reduce water, and to really drive the adoption of the technology, and at the same time to enable the high densities that we're starting to see into the future. So you can't go through any presentation. I think I've heard at every presentation I've been in this morning the mention of AI. And in this context, AI obviously is driving the higher TDPs in terms of the chips. And the kilowatt chip is here today, and the TDPs are only going to get higher. So the key thing for us is that when we talk about the GPU, we don't talk in the singular. We talk in the multiple. So seeing those 8 kilowatt, 10 kilowatt, I saw a slide earlier on, 30 kilowatt servers, they're here today. So when we extrapolate that out to a rack level, what does that actually mean? Well, we're already seeing 50 kilowatt racks, we've seen 60 kilowatt racks, and I know that there's been discussions around 150, 200, and the last presentation, there was even talk about megawatt racks. I'm not quite sure how long that's going to take for us to get to, but certainly the 100 and 150 kilowatt racks are very much on the horizon today. When we actually then look at the landscape, and quite interestingly, we look at 2024, we can see that a number of things from this research from Omdia. The first thing is to say air's not going away, and I think our friends at Schneider mentioned it, that AI will be in different locations. Not all applications will actually be AI, and not all data centers will require liquid cooling. So that's important to know. So air will still be there. In terms of liquid today, it's pretty much confined to some specialist applications, things like HPC, crypto, GPU as a service is certainly starting to use it. And you've got some very specialists like the guys at Ali Cloud and even here in India with PhonePe that have been doing immersion for a number of years. And in terms of the direct-to-chip, we're really now starting to see that take off in terms of the hyperscalers. As we start moving down to 2028, however, you can see that not only is the market pretty much doubling, the size of the liquid cooling is as well. And that's obviously being driven by, again, AI, but what we expect to see in terms of the growth from the AI chipsets and the applications. When we talk about liquid cooling, we talk about direct-to-chip, and we talked about immersion. Where we're at today, 75% is probably direct-to-chip, with the rest being immersion, as we mentioned, those specialist applications. But where we're expecting to see a little bit of a pivot is around 2026, 2027, when the barriers to adoption of immersion cooling, we'll talk about those shortly, are overcome, and we start really building up so that immersion we expect to be about 40-45% of the actual liquid cooling market. So as you can see, liquid cooling is going to happen. It's going to be here. So we need to understand how we're going to work with it and how we're going to collaborate to make sure that we have smooth and simple installations. Oh, I've got a bit of a technical problem. It stopped. Okay, there we go. We're back up. Okay, so as you mentioned, just really briefly in terms of the technologies, where we see it and where we play. Obviously, the direct liquid cooling, cold plate cooling, direct to chip, many different names that we're given this type of cooling. Obviously, it is more efficient than air cooling. But there was another important statement made that we are moving to this because with the latest chipsets, we don't have an option. So that should also be borne in mind. This technology gets rid of anything between 70 and 80%. I am hearing a figure that's a little bit lower now. And that's because some of the other components within the servers, their power increase and their heat density is increasing as well, thinking specifically around memory. But if we take 70 to 80% as a benchmark, we won't go too far wrong. We are talking about the densities up to 150 kilowatt, as we mentioned. And the nice thing about this technology, and probably the reason why it's really taken off, is that we can add it quite easily into the existing facilities. So there's obviously it's more readily accepted. The maintenance regimes are similar to what we already do today. So that's really important for us. What is important to also note, though, it still requires significant air infrastructure as well. So I know the guys over at Stutz, they're showing their rear door heat exchangers. Most of the big vendors have got rear door heat exchangers to work in combination with the fan wall technology as well. So arguably, it's quite a complex setup. And that complexity, what I mean there is we go from a cold plate to a hose, to a manifold, to a valve set, to a header pipe, into a CDU, and you've got different materials in there as well. So arguably, there's a lot of infrastructure in there. And the other added piece of information is that we're going to be running a water-based fluid in there. And although people may tell you that PG25 using deionized water, it is still electrically conductive. So you need to bear this in mind. Latest designs, and the standard design for a CDU is about 1.5 litres per minute of flow per kilowatt. So when we extrapolate that out to a megawatt, that's 1,500 litres per minute, okay? And that's a significant amount of water you're now moving around your data center. So immersion cooling. One of the nice things is we're pretty much taking away all the heat with immersion cooling. Arguably, it is less complex. We've got the tank, we've got a heat exchanger, we've got some pumps, probably a little bit of controls in there as well. So arguably, it's a simpler unit to work with. When we work with immersion, we're taking fans away, so we're taking points of failure away. We're also taking points of energy consumption away. So that basically means that we can get enhanced reliability, but we can also have an added benefit of reducing noise as well. For anybody that's been in a data center that's running the GPUs, I use the phrase that scream like a banshee. So that's one of the benefits. And we're even seeing some of the larger tanks, the immersion tanks nowadays, up to 375 kilowatts in a very condensed footprint. So we're really starting to be able to deploy high density loads in small areas. Fluids, obviously, we mentioned the water-based fluid. This technology is using hydrocarbon-based oils. And obviously, that's probably where you might imagine we come into the equation. The key thing about this, it's not electrically conductive, it's all safe, so when we're putting the servers in the oil, we've got no problems. However, why aren't we all doing it today? Well, we have unfamiliar maintenance regimes. You can see from my grey hair, I've been around for a little while, putting a server into a tank of oil just doesn't compute. So we're having to change people's perceptions and ideas, and these things have happened over many, many years, and we need to change that. The hardware warranty. Dell's XE9680, its workhorse of AI server, worth about 300K. They won't provide a warranty. Who's going to put that in a tank of oil? No one put their hand up. Okay, so we need to get the big guys on board in terms of the warranty. There are ways of overcoming it. That we work with partners that actually provide the warranty. They are a Dell partner that does this as well. But what you're starting to see is instead of immersion-ready servers, we're starting to see immersion-born servers, and that's going to make a big change in terms of the efficiency of the equipment and the throughput of data as well. Standards and material compatibility, obviously, when we're putting these kind of things into these expensive servers into oil, we're dealing with lots of different plastics, lots of different metals and elastomers, so we need to make sure that they're going to work happily together. And the final one is signal integrity. There's been quite a lot of discussion around the NVLink that is used by NVIDIA. It has been an issue. There's been up to 9% losses, and NVIDIA say basically anything below 7% they're okay with, but over 9% it starts to become a little bit of a challenge. There are 2 companies today that have solved that challenge, so the others will now solve that challenge as well, and we'll start to see this help with the adaptation and the adoption of the technology. So why collaborate? Well, as you've probably heard from many different presenters today, we are very much in our infancy here. I know of 3 or 4 instances of installations of direct-to-chip and immersion where there have been significant problems. Okay, so the key thing for us as an industry is that we work together. It was mentioned in the first panel today, which from the hyperscalers and the large colos, and it's been mentioned in others. So when I actually put fluid in the middle here, I do it for one specific reason. I've just introduced a single point of failure into your data center. And I'm not sure whether everybody actually realizes that. we've spent years and years taking single points of failure out of a data center, and we've just put one back in. So the engineers probably don't like it too much. So when we look at and talk about collaboration and the people that we have to work alongside and with, the first is that part of the circle is the guys that we have to get the tick of approval. So those are the silicon guys, so the work that we do with NVIDIA, Intel, and AMD. Then there's the server guys, so the work that we might do with the likes of Supermicro and Dell and HP, etc. Then we get into the actual components, because you're not just going to put a standard fiber cable in there or a standard fiber connector or a standard power lead. We've seen power cables that have been put in some immersion oils. When they're standard, they start to bulge, and you can imagine that it loses power. So we work with all of these guys, the likes of this Formerica's and those kind of companies. Then, of course, the Schneiders, the Vertivs, the Stultzes that we see around here today, we need to make sure that we play happily with their wetted materials, as we call them. So all the different components, because we're going to be touching them, whether it be in the direct chip world or in the immersion world. And then we come around to the guys that are actually going to install the IT. So how do they need to handle the IT when they're putting it in an immersion tank or connecting on a hose, or they're looking to put additional PG25 into the system? There we go into the mechanical contractors, because we know they play their part, the co-location, the DC operators, and I know Roy from CBRE was talking about it, and the guys from JLL as well. They're the guys that are going to be operating these facilities for the next 20 to 30 years. So they need to we need to have discussions with those guys as well. So am I just saying this for the sake of it? Is there actually any evidence that we really need to? So about 4 weeks ago, I was contacted by somebody I've known for a long time, working at one of the hyperscalers, and he'd been offered some fluid to put in his CDU at a project in Malaysia. Okay, this was the fluid, and as you can see, the majority of it is in Chinese. My Chinese is not good. It's probably as good as my Indian, but I could make out a number of words. One of them was Chrysler, one of them was Ford, and one of them was GM or General Motors. They'd been offered engine coolant to put in their CDU. Okay? So this, in some instances, is the level of education that we have within the industry, and this is a big warning sign. So this is why we need to work together. The next part is, if anyone's seen the inside of a cold plate before, this is a cold plate. That is biofouling, or algae or fungi that is grown on the cold plate. That is a result of poor maintenance of the fluid, the propylene glycol. And as you can imagine, that is stopping the cooling onto that chip. And that chip is probably going to die pretty quickly. So this is why we need to work together, so people understand that this fluid isn't just put it in and forget about it. We need to maintain it on a regular basis, and we need to monitor it as well. So I promised that I'd mention where we fit in. So we do offer solutions for both direct-to-chip cooling and for immersion cooling. So we have our synthetic hydrocarbon solutions for the immersion. We have a couple of products. I know we were talking about some car analogies before. Our DC20 is low viscosity, reduced pump power, and all about performance, but the trade-off there is a lower flash point, and that might be important. We have a DC15 that is designed to meet the OCP standards. We also do the PG25, and we'll also be in the PG25 world. We'll be adding some services and monitoring in 2025. As part of our drive for collaboration as well, we also opened a liquid cooling center of excellence earlier in the year, and that center of excellence is designed to enable us to co-engineer with customers, with different hardware vendors, etc. That enables us to unlock new performance for their cooling equipment, but maybe even drive efficiency as well. It enables us to test all that material compatibility, the flammability and the stability testing to make sure there's not going to be any problem when we do put that 300K server into the tank. And it also allows us to work with the different parts of the ecosystem for them to test their products in there. And we can even take technology stacks and prior to deploying either in a POC or a full production environment, we can test it and we can drive efficiencies within there. So with that, I'll just leave you with a short video that's going to show you some of the technologies within that facility. It's only a minute or so, and look out for some different technologies. You'll see the immersion tanks, but you'll also see some precision cooling from organizations like Isotope and Airsys that use a spray system onto the servers. So I'll just, hopefully this plays okay for you. No sound. So this is the Isotope system. So it's actually a precision unit that uses dielectric. It drops the dielectric directly on top of the server itself, and the motherboard and the memory is just shallowly coated. But as you can see, it's in standard rack format, and you're able to maintain it in a more standard format. So these are load banks that enable us to test the different properties of the fluids, and again in different tanks. And not only are we able to dictate what's going on in the tanks, but we've got full control of the primary circuits as well for the testing. The facility is based about an hour outside of London. The guys are very, very proud of it. So if any of you ever find yourselves in that neck of the woods, then we'd be more than happy to host you there and show off the capabilities we have. Next year, we're actually going to be deploying some CDU technology in there as well. And this is our essentially, we were talking about edge earlier on as well. So this is a good example of a potential edge application. So in this one, we actually do the technology stack testing. So you can see some different equipment that one of the customers was using. Okay, and that pretty much concludes the presentation. Obviously appreciate the time you've taken to come and listen. Any questions? I'm around all day and on a panel a little later on as well, so look forward to engaging with everyone. Thank you.